All right, these are not your homework problems in homework 9.4, but they are problems that are very similar and I hope you find very helpful. So what you're going to do today is you're going to open your notebook and you're going to write at the top, exponential word problem notes. And what you're going to start by doing is writing down the first problem. So pause the video, write down this first problem, and then unpause the video and we'll work through it together. So I picked out 3 examples what I think might throw you off. And so as we work through them, it should give you some help on getting the hardest of the exponential word problems in your homework. So Cesar invests $2,000 in an account that doubles every 7 years. This is the tricky part, this every 7 years. The exponential equation for it is the amount he has is equal to the 2,000 he already has times, well, what it's multiplying by is it's doubling, so that's multiplying by 2, but it only does it every 7 years. So the way this works is we say it's going to double, the number of times it's going to double is t divided by 7. The reason this works is when t is 7, after 7 years, 7 divided by 7 is 1. It'll be 2 to the first power. You'll be multiplying by 2. After 14 years, 14 divided by 7 is 2. 2 squared, you'll multiply by 2 twice. It will have doubled twice. After 21 years, it will have doubled 3 times, so there will be 3 multiplying by 2's, etc. Now it says how long until he has $10,000. So that's the amount we want to have. You always want to see, like, is it saying how long until? If it says how long until, we got to solve for t, and he has $10,000 is the amount he's going to have. So that's what we're substituting here. And we want to solve this. So this is, from here you should have no trouble, but we'll go through it anyway. This is an exponential equation. So you need to get the exponential part by itself. So we get 5, 10,000 divided by 2,000 is 5. And now we need a calculator. So you'll need a calculator for this. And we need to do log base 2 of both sides. And I'm going to squeeze this in here, log base 2 to cancel out the exponential. And to do log base 2, we press math. We go to log base, which is A. You can scroll down or scroll up. Log base 2 of 5 is 2.32. We don't round in the middle of a problem, so we're just going to leave this for a second. We're going to write 2.32, but we won't actually type into our calculator 2.32 because that's not the exact answer. This is much closer. So this is t over 7. And then to get rid of the dividing by 7, we multiply by 7. And so we're not actually going to do 2.32 times 7. We're going to do this exact, or the closer to exact number, times 7. And there we are, 16.25. Now, t equals 16.25, and we want to say what the units are here. Because it was doubling every 7 years, the time is 6.25 years. This should make sense because it has to double once after 7 years, that's 4,000. It doubles again after 7 more years, that's 14 years, it'll be at 8,000. And so in a few more years, it'll go from 8,000 to 10,000. Okay, so our next problem, go ahead and pause your video as you write this down. Bacteria are growing exponentially. At 8 a.m. there are 500 bacteria. At 11 a.m. there are 2,000 bacteria. How many bacteria will there be at 4:30 p.m.? So the first thing we need to do is set up an equation. We know, we're going to say it starts with 500. We're just going to say it starts at 8 a.m. So we're going to say the amount of bacteria is equal to 500 times, here's the thing, we don't even know what it's multiplying by. It doesn't say what the constant multiplier is. It doesn't even say what the rate is. I'm going to choose a base because it doesn't actually matter what base you choose. You can choose doubling. I'm going to choose e here because e is actually the most common exponential we use, and you want to get used to using it. So it's going to be 500e, but we don't know the rate. So I'm going to put r, and we also for now, I'll put time. So let's see what we know. At 11 a.m., there are 2,000 bacteria. So there are going to be 2,000 bacteria after, how much time has passed? Well, from 8 a.m. to 11 a.m., 3 hours have passed, and so it's going to be rate times 3. Okay, this will allow me to solve for what the rate is, and once I know what the rate is, I can find how many bacteria there are at 430. So I divide by 500, take the natural log on both sides. One of the reasons we choose base E is because it's easier to type in natural log than some of the other logs. It's right there on your calculator. You don't have to press log base. So 3.68, actually it rounds to 9, equals 3R. Divide by 3. R equals, let's divide this exact number by 3, 1.23. So this is going to be our rate. Now, this is not exactly the rate I got. Again, I'm not going to use this number. I'm going to use the number that's in the calculator that's more precise. Oh no. My battery is low. Hopefully it will not run out. Okay. So now let's go back to it. Now that we know that R is 1.23, our equation becomes A equals 500 E to the 1.23 T. So now it says how many bacteria will there be at 4:30 p.m. So that's what we want to know. We want to know what the amount will be. Well, it's going to be 500 E to the 1.23, and then the time is how many hours have passed from 8 a.m. And so 9, 10, 11, 12, 1, 2, 3, 4 and a half. So it's going to be 8.5 hours until 4:30 p.m. And so now we can type this in. It's going to be 500 E to the we're not going to use 1.23. We're going to use this number up above. Just press up to highlight the number and press enter, and it'll copy that whole number there, times 8.5. Gives us that by 4:30, there will be 173,03740 bacteria. So what's happening here is it started out not giving us what the rate it was growing by, so we had to choose E as a base. We solved for what the rate was, and we used that rate to figure out then how many bacteria there would be after another time. All right, our last question, last one we're going to do. A radioactive element has a half-life of 5 years. How long until 10% of the original amount remains? Remember, half-life is the amount of time it takes for there to be half as much of the material. So the amount of the material is going to be how much you started with, but it doesn't actually tell you how much you started with. So I'm going to choose it like, I'm going to just choose a number B for constant. There's some number that it started with. It doesn't even tell us. Times 1/2, because it's multiplying by a half, every 5 years. So that's going to be T divided by 5. And what they want to know is how long until 10% of the original remains. So 10% of the original means 10% of this B. It's 0.10 times B. It turns out it doesn't matter what you start with, you'll always end up with the same answer, because to get to 10% of it, watch what happens when we solve this. Oh, man, my 5 became a 2. What happens when we solve this is that we divide both sides by B, and B will go away. So we end up with 0.1 equals 1/2 to the T over 5. And from here, we can solve this using a log. So log base 1/2 of 0.1 equals T over 5. We need to do this in a calculator. Log base, again, log base is you press math and go down. Log base 1/2 of 0.1 is 3.3, and that's T over 5. So we're going to multiply by 5 on both sides. Again, when I type it in my calculator, I'm not going to do 5 times 3.3. I'm going to type in 5 times the answer that was up above there, And that'll give me a much more precise answer. So I get 16.61 is t. Again, I should say the units here. T is in years, so 16.61 years is how long it will take for there to be 10%. You can play around with this. You could plug in any number you want for a starting amount, and you'll see that after 16.61 years, you'll have 10% of what you started with. The way you should use these videos is I hope you were going along with it and like calculating, pausing the video as needed, and not just writing stuff down. If you were just copying what I did down, you're probably not learning math very well. You can also come back to this video later if you need it for help during your homework. But now that you've completed this, you can start your homework. Good luck.